Hello, assalamu alaikum, sat sri akal, namaste, vanakkam. I am myself Tofik Naik, you know me. After a long time, we are meeting with you with a new topic, semiconductors. With the new topic, semiconductors, we know we have a less time, so we will start with ending easy topics. We will cover first. Okay, now the topics from where we will get 100% questions like that topic we will cover first. Okay, now let's get started with our new topic of semiconductor, which is the final chapter of your 11th and 12th physics. Okay, now why we are studying this? Because it is easy and you can score easily marks here. For NEET students, those who remember the direct formulas, they can score easy marks. So let's get started. See, before 1930, before 1930, to control the flow of electrons, it was very difficult. Sir, why we will control the flow of electrons? See, when you control the flow of electrons, you can vary the current. If you vary the current, then you can know what is the output work you are doing. So if you control flow of electrons, control the flow of electrons, then you can vary the current. Vary the current. Correct. If electrons are moving slow, then current is moving slow. If electrons are moving fast, then current is moving fast. Correct. Now, if current is moving fast, then how it works, we have already studied in chapter 1 and 2. Now we will study. See here, before 1930, it was very hard to have this controlled flow of electrons, because at that time we don't know the semiconductors. That time, before 1930, we used to have a thing called vacuum tube. We used to have a thing called vacuum tube. Vacuum tube. Sir, what is this vacuum tube? It is the vacuum tube, it is like this. I think if you are going to your schools, there you would have seen this. Vacuum tube will be like this, which is a very big. See, vacuum tube is this big, this big. So in this vacuum tube, its full place is empty, and you will have here one cathode and anode, and here the extra material which this will have, some extra materials. Okay, now we don't need to study this. Just for understanding, we are learning this. Okay, now cathode tube. This is called as cathode tube. And inside this vacuum tube, inside this vacuum tube, this is vacuum, no air. Inside this vacuum tube, it is full, no air, nothing. Vacuum tube. It is means inside the vacuum tube there is no air, no air. You know, first of all, no air. Now the thing is, why no air? And why we use this vacuum tube before semiconductors? Before finding semiconductors, why we were using this vacuum tube? Because this vacuum tube helps us to maintain the flow of charges or electrons. This vacuum tube help us to maintain the flow of electrons. Sir, why we need to maintain the flow of electrons? See, there is a substance. If you take any substance, if you pass continuous current, what happens? At one time it will burst. See, one time it will blast. So if you have continue, see, in our houses we see alternating current now. In alternating current is varying. So to vary the current, we need to vary the charges. If we vary the charges, we have a lot of applications. So to have this kind of applications, we used to have this one very big, very bulky vacuum tube. In that vacuum tube, the full place is empty, full place is vacuum, which means empty, and which has a cathode and anode. Okay, now what we'll do, we'll just heat this cathode. Now once we heat the cathode, first thing what we'll do, we heat the cathode. Heat applied to cathode so that it release electrons. When I heat the cathode, it started releasing electrons. It started releasing electrons. Now what I will do? Now what I will do? I will maintain. I will maintain the voltage between this. I will maintain the voltage between this. I will maintain the voltage. See here one thing. If I heat the cathode, electrons start emitting to the tube. Now electron started. Now what I will connect this to a voltmeter. Voltage. I will apply some voltage. Now by varying the voltage, supplying the low voltage, high voltage, low voltage, high voltage, I can control the flow of electrons. By varying, see next point, we apply voltage between cathode and anode. Okay, now one good point. And by varying the voltage, I can have the controlled flow of electrons. By varying the voltage, I can have the controlled flow of electrons. So next point you can write like this. By varying, okay, wait, I will write the point. By varying, once again, what happened? By varying the voltage between cathode and anode, I can have controlled flow of electrons. By varying. Okay, now TO or NS, electrons. See, by varying the voltage, I will have controlled flow of electrons. Okay, now this is how our cathode ray tube works. Okay, now the main disadvantage of this cathode ray tube, see, it was very good. It is a very bulk, and if you give some heat to cathode, it start releasing the electrons. That electrons enter the vacuum tube. That vacuum tube, and I will apply some voltage to maintain the flow of these electrons, either increasing the electrons or decreasing the electrons, increasing the electrons or decreasing the electrons. This is how I maintain the flow. Now, there are few disadvantages of using this. What are those disadvantages? These are like very simple disadvantages. No bulky thing. See, no bulky thing. Sir, you got one disadvantage in mouth. You got one disadvantage in your mouth. Sir, what is that? What is that? What is that? What is that? Very simple. That is a disadvantage. Write down here. Disadvantages. The first thing is it is very bulky. It is very huge. Say nowadays our TV, our mobiles, everything we need semiconductors. Semiconductor to maintain the flow of these electrons. Now to maintain this flow of electrons, we are using semiconductors. Before 1930, we used to have this vacuum tube. Now imagine your mobile phone with a vacuum tube. How it will be? Holding like this. Hello? Yes? Yes? Funny, right? So disadvantages first is it is bulky. It is bulky. It is bulky. And for this we need high voltage. We need high voltage to apply. See, we need high voltage, nearly 100 ohms. 100 ohms. One and 2 points. And one more thing, it has low lifetime. It has low lifetime. And you can even write like this. Here we must have vacuum because if electrons are releasing from the cathode, if it enter in the normal place, it will collide with the air molecule, and this collision make speed of this electron slow. Why we must have vacuum means, if we leave this in normal atmosphere, these electrons, if there is no vacuum, then electrons release will collide with the air molecule, and which makes the speed of electrons very low. Very disadvantage. Headache. Headache. So if you want, you can write it will the speed of electron is reduced when you apply. Let's say speed of electron is reduced when it collide with the air molecules. That's why we need vacuum. Correct. Huge bulky. We need high voltage, low lifetime, and low reliability. 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 Like disadvantages are there. Okay, now at this time, some scientists in 1930, they found that there are some elements, like some elements, or you can say some materials made up of a same kind of elements. Some materials are substances which are made up of very good materials like silicon, germanium, etc. In 1930s, some scientists found that semiconductors are some materials. In 1930, some found that some materials are some, let's say, some elements in some elements we can have we can have controlled flow of electrons in 1930. Or before the in 1930 we found transistors. See, in 1930 only we found the transistor. So like this, 1930 there that time. Okay, now before 1930 no transistor. Transistor means I will tell you later. Transistor, see, in 1930 we built a transistor. Transistors means I think you have seen in your mobiles or in what do you call it, remote and all. See, there is one small circuit like this which will having three diodes like this. Oh yeah, like this. You have seen. It is made up of p junction. We'll see this later. Don't worry. We'll see this exactly later. Okay. Just now I got this in mind, so I'm saying. Now, control flow of in scientists in nearly 1930 or 1930 after, they found that scientists in some elements we can have control flow of electrons. Or they said we can control the flow of electrons. Now, these elements or this element they called as semiconductors. They called as semiconductors. 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 Now, after here it is origin of semiconductors, and they give some important characters of semiconductors. One thing is semiconductors is not bulky. It is very small size. It is very small in size. One thing, and they even say that it has high lifetime. High lifetime and high reliability, and they even said we need low voltage, we need low voltage low voltage to control flow of electrons, and what is there, it is not bulky, it has a high lifetime, we need low voltage to control this. These are all the very important things we found. And still um, semiconductors. So these are very important things which said us to use semiconductors. It has very huge drastical usage. Now, after the development of transistor in 1930, our see nowadays, first first in like 10 years or 20 years, sorry, 5 10 years back, we used to have this much big TV, right? That TV consists of our vacuum tube. Now we are using a LCD, which is called as liquid crystal display. See, first we used to have a TV like this bulky TV, how to write bulky? See, we used to have a TV like this. It is not speaker, man. It is TV. I'll just add TV. TV. We used to have a TV like this, bulky TV. In this, we were using vacuum tube. Now we are using TV like this, simple. It is not bulky, LCD. We are using the LCD, which is known as liquid crystal display. Liquid crystal display. After development of semiconductors, it's very useful in our daily life. The from which you are seeing me, for example, your mobile, that is inside of this there are many semiconductors. Similarly, in nowadays, best example to understand this semiconductors is first we are using a TV. We used to see in the TV. That TV is made up of our vacuum tube. See, one second, it is not a TV, it is like a speaker, it is more over like a speaker. So I will write a TV, perfectly a TV, perfectly a TV. Okay, okay, now okay. Wait. Yeah, it is TV, yeah. Okay, TV. Okay, now, fine, now, take down first. And one more thing, for this we need see, to start a semiconductors, room temperature is also enough. To start a conduction in semiconductors, low heat or room temperature is also enough. So we can say low heat or room temperature is enough. Fine, take down all this point. Uh, okay, now, fine. This is a simple basic why we use semiconductors in our daily life. Okay, now we will start our main thing. We will start. Sir, we need to learn this. See, it is not about a learning. It is about how and why we started something. How and why we started something. If you don't know how and why, then what you will learn? Wow, what a sentence! If you don't know how and why we started, then what you will learn? Wow, super! I am super because I am physics. I am super because I am physics. Okay, now we will start our main thing. From here, your main chapter starts. Main chapter starts. Now how? How? Very simple. See, let us see three things. One conductors. One semiconductors. One insulators. See, I know you have a little basic. At least little basic about what do you mean the conductors, what do you mean insulator, what do you mean the semiconductors. See, in conductors, it has a, it see, in conductor, it conduct electricity very easy. There is no stress to conduct electricity. Conductors are the materials in which current can flow very easy. Current can flow very easy. See here, conductors, current can flow very easily. Current can flow very easily. Okay, now, but if you come for semiconductors, here current can't flow very easily. Current can't flow very easily. And here in conductors, it is because it has huge high free electrons. It have high free electrons. It has high free electrons. Okay, now conductors, there is one more thing. Conductors, here resistivity is very low. Sir, why resistivity? See, resistivity is low. That's why only it is conductor. If conductor conduct the electricity. If something is conducting electricity, its resistivity is low only, right? If a thing is conducting electricity, conduction is more, then resistivity means opposite to flow of charges, right? Resistivity is low, that why conduction is more, right? Correct. Take down first. Now, after that, one second. Hmm. Okay. In semiconductors now, we don't have free electrons. See, we will have, but not high free electrons. Semiconductor is a very good and great thing to be learned. Now, see here, semiconductors will supply it is, see, in I will write like this: in temperature to 0 degree, temperature is 0 Kelvin. Imagine temperature is 0 Kelvin. Then these are insulators. Then these are insulator. Now, if I give you little temperature little greater than 0, if my temperature is little also greater than 0, then it start conducting charges or current. Current. Now, in this, the flow of charges, the flow of current is due to flow of current or electricity is due to electrons. But in this, flow of current is due to electrons and holes. Now, what is this electrons and holes? We learn, don't worry. Now, to be fact, if you heat, say, if you give some high temperature to conductors, it will start behaving like a resistor. See, if you give a little temperature to conductors, then conductivity will become low. See, if you, like this, if you rise temperature, then conductivity decrease. What is the spelling of decrease? D-C-R-E-S, decrease. Correct. But here in this, if you increase, if temperature is increased, then conductivity also increases. Now, if I want to give examples, for these examples are all metals. For these examples are, we can say, silicon and germanium, which are naturally silicon, which are natural semiconductors. Okay, now here if I come for insulator, see, in insulator, if you heat or if you do whatever you want, there is a no flow of electrons, so no current conduct. In this, no free electrons and no free electrons, right? This, and if you increase temperature, then also it don't conduct electrons. Take down first. See, for this you can add one more time. See, there is no free electrons in room temperature. And change this above point like this. If you increase the temperature, then it will start a little flow of electrons, but don't conduct L current. See, it will start, then it will start a low, very low flow of electrons. For example, wood, plastic. For example, wood and plastic. These are the important points to be noted. Take note. Then we'll see one more thing. Okay, now done. Now, see, in metals it is due to free electrons. In semiconductors it is due to holes. And what is this holes and all? We will discuss very clearly. Relax. We will discuss very clearly. Okay. Now see this semiconductors. Now I said now this is a very beautiful thing. Semiconductors. In semiconductors there are no free electrons, but we can create the free electrons. See, in conductors there are free electrons are there, but in semiconductors free electrons are not there. Here we can create the free electrons, and even we can maintain the free electrons. We can maintain the flow of free electrons. That's why it is very beautiful. That's why it is very beautiful. Okay, now done. Now let us dive into one more main important thing, which means we are going to understand clearly what is the semiconductors and why it is semiconductors we need. Why we need semiconductors and what happens in these semiconductors. Okay, now. Okay, to understand this, we need to learn one simple thing first of all. We need to one simple thing. We need to learn one simple thing, that is, see, for example, if I have an isolated charge, sir, what is this isolated charge? See, let us take one isolated charge. Let us say an isolated charge is x. Okay, now in a small, let us say an isolated charge is x, and one more isolated charge here x, which has a little more distance. Now, if it is a charge, if it is an element, sorry, not a charge, take an isolated charge or take an isolated atom. Take an isolated atom. Don't take a charge. Take an isolated atom. Then you will understand very clearly. If you take an isolated atom, now it is a one atom, and it is one atom. Okay, now in a gas. Now see here, this atom will have orbit, and this atom will also have a orbit or shell. Now, for example, here there is one electron is there. Now, if I want to move this electron from here to here, distance is very high. If I want to move this electron from here to here, first what I need to do? I need to remove this electron outside. First I need to remove. Then I need to add here, right? Then I need to add. Right? It is like if you have two houses. One, say it is like here is your house, and here somewhere your friend's house. Now, if you want to go to your friend's house from your house, first you need to come from out your house. Then you need to enter to your friend's house, right? Then you need to enter to your friend's house, correct? Similarly, here also, if you want to send this electron from this gas, this atom to this atom, first I need to remove electrons from inside to outside. Remove. Then I need to make this go inside, correct? Normal case, when they have a single, isolated means single atom. We are talking this all about single atoms, okay now? Single atom. We are talking this all about single atom, one single atom. That time, this very simple phenomena can happen. Now, this is not the real case. See, in our real life, do elements or object exist in one atom? Can you see one atom? Oh, sir, one atom, one atom. Sir, this chalk piece is, sorry, this marker is made of one atom. Funny, right? Here, the main thing is objects are all made up of n number of atoms. N number of atoms together made a small substance, right? Solid substance or liquid substance. In that, there are n number of atoms. Here, isolated atom. In this, you can remove and you can add very easily. But if you have a solid state or n number of atoms, if you have a, let's say, solid state or n number of atoms, that time, what happens? For example, see here clear cut. I have a small x in a substance. I have a small atom x. Sorry, a nucleus. Here one atom. Here one atom. For example, I am saying here one example. Here one atom. Here one atom. Sir, it is x any element? No. X is just any element. Any element. Okay. Now it will have orbit like this. It will also have orbit like this. It will also have orbit like this. Same for this. Same. Like, correct. Now if I write one more orbit, see here, now the main game starts. If I write one more orbit here, okay, here if I go to right orbit, what happens? See, orbit overlap. If I write here one more, orbit overlap. Orbits overlap each other. Here, if I write one more, see, the beauty, it is only physics. It is only physics. See, single isolated atom is very simple. Now here, it is not like that. It is n number of atoms. In a substance, we are talking about a substance because in nature substance only exists. Single atom don't exist. Right? It is exists but we can't see. Substance we can see. Substance is made up of n number of atoms and solid state. At this time, the shells are not attached to each other or they are not bonded. We can easily transfer electrons. But here, in a substance, atoms are very close to each other. Due to this closeness, these shells overlap with each other. Now, see here, very simple. If in this case, if I take an electron, see when it is in a ground state, I can say the energy of this electron will be like minus 19.89 eV. Very simple. I can say like this. Or it will go to n is equals to 2 orbit. Then I can say how much it is 6.8. How much? What is it energy? 3.4 eV minus. And here, if we go for n is equal to 3, then I can say minus 1.6 eV. Like this energy varies, right? Now, if my electron is in here, I can very easily say that the energy of this electron is this. Sorry, 13.6. Energy of this electron is 6. Here it is, I can say very easily the energy of this electron is this one. And if it is here, then I can say energy is this one. Correct? Very simple. But here it is not the case. Shells are overlapping. When it is overlapping, then energies are combining. See, this shell overlapped here. This orbit overlapped here. Here simple. The electron from first orbit, which has energy of this, come outside and enter into here. Very easily you can say. But here, from which orbit? Hello sir, from which orbit? very funny, right? Do you need to think this case? Yes sir, we need to think this case. Very good. Think this case. Now, come. I will show you. I will give you the best thing. Isolated charge. In isolated charge, distance between atoms are high, right? Like this, and to send a charge from one atom to another. First make it come outside, then enter into another. First, see, it is a normal thing, we are making notes. Make as you understand. First make it come out, then enter another. Right, this is the case we are seeing here. First come out, then enter into another. But here in solid case it is not like that. In solid substance the distance is very low. The distance between atoms is very low. The distance between atoms are very low. And here electrons don't have a perfect energy. Here electrons will have a perfect energy. Here electrons will have a particular energy because it exists in only one orbit. But here electrons won't have a particular energy due to overlap of orbits. Electrons won't have a particular energy due to overlap of the orbits. Not all the electrons. Not all the electrons. There is a condition. Not all the electrons. Valence electrons only. There is a condition. Only valence electrons. This is only. It is only not valency. It is last stage we call see the outermost electrons, you can say outermost electrons. Okay, this is very good. Outermost electrons. Outermost electrons. Okay, now how and why I will explain you. See here carefully. Write down this. Once it is done, I am going to explain you this case totally. Clear? Yes, sir. Why, sir? Okay, sir. This is what going in the school, sir. See, understanding is very important. I am going very slow because this chapter gives you very easy. This chapter is take the marks, 4 marks, take it. Like this it goes. So we need to learn it very slowly and very understanding, very understandingly. Okay, now I am going to explain you this why and how. See, if I take 2x atoms, now if I draw orbits, okay, for a small change I will draw orbits like this. Okay, fine. Now orbits, see here, it is my energy levels. It is my energy levels. It is my energy level. Right. It is the outermost, and at this point electrons are overlapping. And at this point, sorry, not electrons. At this point, our orbits are overlapping. At this point, orbits are overlapping. See, the electrons here are very close to our nucleus. Here, electrons are very far away. Here also electrons are present, but very far away. Now, if you go upside, there are still more. We can see still more energy levels. We can see still more energy levels. See, here electrons are not overlap. At this point, electrons are overlap. Sir, okay, overlapping is happening. Why? What happens if it overlap? Why you are making an issue? Why? What happens, sir? See, something happens. What means? Just say like this. If it is a small, okay now. If it is a small, and here also, let's say one small. As soon as it got overlap, the electrons present here, okay, take like this, okay, now electrons are here. Now simple case, if one more thing comes here or one more atom is here, till now it is simple, it is not overlapping. Till now it is not overlapping. It is separate, it is separate. It is separate, it is separate. It is separate, it is separate. Till now it is not overlapping. Once it start overlap, then this nucleus will be like electron come towards me also. Electron come towards me also. This nucleus start attracting this. This nucleus also start attracting this. On this electron, this nucleus will also have rights, and this nucleus will also have rights. It will become a common area. It will become a common area where this nucleus will also act force, where this nucleus will also act force. This will become a common area. It will become a common area. See here, the common area is this one. It is in general way, it is common area, because here orbits are overlapping. Then this electron, this nucleus is like come towards me, and this electron also come towards me. For this electrons, this nucleus is come towards me, and this electrons, this nucleus also come towards me, like come towards me, come towards me. Sir, understood? Purida? Illa sir. No sir. One more example. See, one more example. One more example. One more example. Okay, imagine you are in a colony. You are in a colony. You are in a colony. What colony, sir? See, I will write a small buildings. Building A. Here. Building B. Okay, now building A and building B. Now this is no, I am not satisfied. I am not satisfied. I am not satisfied. Okay, let us take a small, like this one, house. Okay, now one house, and this side it is your room, and this side it is your parents' room, and this side it is your brother or sister. Now in this room, you have your own rights. You have your own rights, and in this room, your brother has your brother has his own rights, bro. Here, parents, right? In this room, your brother don't have any rights. In this room, you don't have any rights. In this room, you both don't have any rights. But for example, just imagine you brought something snacks for eating. Now, if you keep here snacks, then on this snacks, your brother will also like, okay, I will take this, I will take this. Your parents also, I will take this. You also, I will take this. This is a common area which you three will use, right? Common area. Here only you are using, here only your brother is using, here only your parents using. But this area, all are commonly using. Our hall, in our house's hall, where we sit together, watch TV. That is the only place we are together, right? Here, in this area, all have rights. When something, for example, this snack something come from your room to here, then on this both will have rights. Similarly, if something snacks or anything come from this room, parents to here, then on this snacks you both will have rights, right? Till the snacks are inside the room, only this will have rights. Parents will have rights. Here only you will have rights. Here only you will have rights. As soon as it come to hall, then all having rights. See, it is like we'll buy a kurkure packet or chips packet. We'll hide and we'll go to room and alone we'll eat seeing TV on Netflix. Because we know when we come to hall, if I am eating, my brother will take some snacks, my mom will take some snacks. Correct? Rights? Understood? Understood? Now I think understood. So similarly here also, till electrons don't overlap, only one will have rights. Only one will have rights. That is inside. Now, as soon as it overlap, then on these electrons, this nucleus will also got rights, and this nucleus will also have rights. Okay, now, and this till this point, including this till this point, we call it as valence band, and upside here it is called as conduction band. And when electrons move from here to here, then only conduction happens. This we will see in next class, don't worry. Now you understand properly what is this, why electrons, see why this behaves like this, and what happens in isolated charge, what happens in a solid state. If you learn this, then in further you can easily learn everything. Okay, now these are all a basic class. We are doing a small basics today. After this basics, then we will learn. Now here, due to overlap of, write like this, due to overlap of orbits, electrons on overlapping orbit, electrons on overlapping orbit will become a common area, on which all the nucleus have rights, on which all the nucleus have rights. So this is all for understanding. It is not what we are driving. See, first to drive in the swimming pool, we must learn the basics. These are the very very important basics where you don't learn in other places. Only you will learn in added Tofik meaning. Because here we teach a quality content, not quantity. Okay, now. Okay. Then. Electrons below the common area or including the common area are called valence band, upside conduction band. This we will see in next class. Don't worry. Now, I think we can end this. Why this we learn? Why the main motto of learning this is, in a single part, in a single isolated charge, we can easily remove the electron and send the electrons. But in a solid state, it is very hard because here, see this point, electrons won't have a particular energy due to overlapping of orbits. Once electrons overlap here, that time to decide whether what the energy of this electron, it's not very easy as we see. Okay, now that's why we give this point. Now after that you can say one thing, sir, what is the use we learn this here in semiconductors? See, semiconductors we can divide on the based on their covalent, what is this? Valence band and conduction band. There is a division of semiconductors on the based on band. For to understand that one, we need this one. Okay, now without knowing the semiconductors, without knowing this thing, if you learn directly, you will memorize everything, but it is not useful. So we learn this. Take down very fast. Okay, fine. Now till this chapter, we have learned the full basics. Vacuum tube. See, vacuum tube, it is not like a neat topic. It will come in neat topic. 100% neat it will come. But you never know what comes in neat and what comes in IIT. So we must be prepared for everything. And the vacuum tube is a base for this chapter. If you don't know vacuum tube, then you will understand this. But how we came, we won't get. So it is on vacuum tube. Then why semiconductors? When semiconductors? And what is semiconductors? We learn. And after that, we learn what we learn, if you have a single isolated charge and if you have a compound, if you have a substance, why it is very hard to electrons remove or add, and what happens in solid state, we learn this. See, in this universe, isolated charge, isolated atom is very hard. We don't have isolated atom. Isolated atom only exists in a laboratory, that too for very microscopic. And in universe, everything is made up of our everything is made of our solid substance or n number of atoms. So what happens in the atoms and what happens in the isolated charge, we learn. Now next class, this thing we will add for our semiconductors, and we will divide the energy band and energy levels. Energy bands, energy levels. That is very simple. See here, energy levels are there. Energy levels 1, 2, 3, 4 energy levels. All together, this called as energy band, and this all together is called as energy band. Here, this covalent band, valence band, it is conduction band. That's all. Okay. So I think today is enough for basic of semiconductors. From tomorrow, we are going to start. We are already started. So we'll meet in the next class. Till that, bye bye, goodbye, take care.